Hello everyone. This video will talk about the demonstrations and discussions on practice exercise A for the lesson intended on the linear equations in one variable involving absolute value. Now, if we talk about absolute value, we always talk about the positive distance of any number from zero. However, if the absolute value notation contains an expression, there is a unique process to solve for the possible values for the variable which can make the equation true. In this given situation, before we proceed to number one, if we have an expression here, absolute value of x is equal to 3, the possible values which could actually be substituted here that will satisfy this given equation is that x can be positive 3 or x can be negative 3. Okay. As you can see, if you're going to substitute x 3 here, absolute value of 3 is 3, correct? Negative 3, absolute value of negative 3 is positive 3, which is also equal to here. This means that both of these results are acceptable. Now that we have checked it, we could come up with a solution set containing 3 and negative 3. So this is actually the process or the concept that we need to follow for items 1 to 4 to solve for the solution set. Since we're going to solve for the solution set, as a reminder, before we could come up with a solution set, we need to do the checking, because let us not be what they call that negligent when it comes to our checking, because we can only accept solutions and we could only come up with solution set if we are assured, or we are already assured of that the values for x are already solutions by means of checking. So let's try to apply the same concept with number one. But here in number one, we have the expression 6x. So to do this, simply apply here the two cases. We can consider this case one and this case two. Case one is taking the value of the expression here, not just the x itself. So you have here for case one, you have 6x is equal to the positive of the value here, positive 3. In this case, 6x is equal to positive 132. Second case, we'll use the same expression, same here, 6x is equal to, earlier it was positive, now it will become negative 132. So that's the concept here. Generally, it is stated in this way. You have absolute value of x is equal to any value of a. So the first case is x is equal to the positive of a, and the second case is x is equal to the negative of a. Copy, copy, positive, negative. Okay, so we apply the same concern here. Now that we have these two cases, we are going to solve them independently, separately. That means whatever will happen on one side, one case will not necessarily affect on the other case, though there might be some processes that will actually be similar to both, but not necessarily all of the values there. What I mean here is dividing both sides by 6. Do we need to divide this by 6 because we are going to solve for the possible value for x? We are also going to divide the other side here. But the same thing will be applied here as well, because this is also 6x here. So again, we may have the same items to be divided here, but again, we need to answer them separately, independently, because there might be instances that they will not be anymore the same. So let's try to focus first on case number one for an item number one. So we have here x is equal to 132 divided by 6 is actually equal to 22. Let me check that first. 6 times 2 is 12. 2 carry 1, 12, 13. That's correct. So the first answer here is 20, positive 22. Okay? So we are going to proceed with the second case. So x here shall become negative 22. So both of these, as you can see, They are actually just simply opposites, positive and negative value for 22. But before we could come up with a solution set, we need to do the checking. Checking is by substituting our resulted value here in the given equation. Again, I need to repeat, in the given equation, do not just substitute these values on the cases. Do not do that because they might be they might result to the same value, but they may not represent the given expression. So substitute to the given expression. For case 1, you will have your absolute value of 6 times 22. Is it equal to 132? Again, when we check, notice that I use here question mark because even if it's really obvious already, you just simply use question mark because our goal here is to not predict the outcome of both sides, but to make sure that both sides are equal. So we have here 6 times 22 is 132, and here 132. Again, even if it's that too obvious, still put question mark. Absolute value of 132 is 132. The other side is also 132. They are now the same. We have checked this. Therefore, 22 is not just an answer, but more importantly, a solution. I mean, positive 22. Okay? So this is already a solution, and we could come up with a solution set already. But still, we have another case here. So let's try to determine the checking for the second. So you have 6 times negative 22. Is it equal to 132? Again, we use the given equation. So take note that this is not negative. Okay, negative is already part of the case, but the given was already it was an actual positive. So you have here 6 times negative 22 is negative 132. The other side is also 132. Question mark still. Negative absolute value of negative 132 is positive 132. The other side is also positive 132. They are now the same. Therefore, negative 22 for the value of x is also a solution. Now that we are sure that both of them are results, we can come up with our solution set, and it shall contain the values 22 and negative 22. Okay? As a reminder, we are using here a set in the form of roster form because we are listing the possible solutions. And since we only have two possible solutions, we have two solutions rather, not possible solutions, because we already assured of that they are solutions. So we have two solutions. We can only we may use the roster form, not anymore the set builder form. And aside from that, in the roster form, arrangements of these solutions are not anymore necessarily. So if you may say here, I have negative 122 first and then positive 22, or the other side, rearrangements does not necessarily matter as long as the solutions are there, no more, no less. Look at the number of solutions we have here. We have two solutions. When we talk about linear equations in one variable in the previous grading, we only have one solution. But when we talk about absolute value equations, the short term for linear equations in one variable involving absolute value, I might be using that most of the time. Absolute value equations, when we talk about them, we have maximum of two possible or two solutions. And it is actually brought by the concern that when we talk about absolute value, we may take the positive and we may take the negative. So let us try to apply the same processes here in number two. But the difference between number two and number one is that in number two, it's already in as a form of binomial. Nevertheless, let's try to apply the given other cases. So for case one, do not just simply use x, but it should be the whole quantity x, x plus 5 equals positive 9. That's case 1. Case 2 will take the same binomial x plus 5, but it will be equated to the negative of 9. Okay, so let's continue. Let's again solve them independently, separately. So I might say here, I will just do this one, this process, the vertical method for the property of equality. So I will subtract both sides by 5, both sides. So that becomes 0, 5 minus 5. I will have here x is equal to 9 minus 5, which is 4. And the other side as well, minus 5, here minus 5. So that becomes 0 again. So x is equal to, take it of this is where some of us will still be confused. We go back to the concept on integers, addition and subtraction of integers. This is actually negative 14. Okay, so please review your integers here. Now that we have these two possible values of x, do not immediately say, I'm sure of it. I have 4 and negative 14. Some of you might be doing that. Okay? But if we talk about solution set, checking is really required. Don't worry in assessments wherein I will not be necessarily asking your solutions. Some of you might what do you call that, skip that process, but in items wherein I will be requiring to show solutions, you need to show all parts of the solutions. That means the cases, the checking, and the solution set. So before we could come up with the solution set, okay, I don't know if we could come up with the same. Let's do the checking first. So again, we will use not this one, but the original. So you have the quantity for 5 between inside the absolute value notation. Is it equal to 9? Again, even if it's too obvious, just simply complete the processes and until you can come up with an equality on both sides. So you have 4 plus 5 is 9, question mark. Absolute value of 9 is 9, is equal to 9. They are now equal. Therefore, 4 is a solution. For the second checking, you have negative 14 plus 5 is equal to negative 9. And then negative 14 plus 5 is negative 9. I question mark. I forgot. Sorry. I made a mistake here. When we used the original, it was positive 9. That was the mistake. Sorry for that. I did my warning. Okay. So this is not negative 9. It should be the original. So you have here 9. So absolute value of negative 9 is 9. The other side is also 9. They are now equal. Therefore, negative 14 is also a solution. Now that we are sure, we still came up with the same solution set earlier. So some of you might say, I'm already assured of sir, so why do I need to show checking? Again, it's an essential process. So you need to reach with that. And of course, you might come up with a situation later that checking is very important because there might be issues with your solutions. Those will be discussed by practice exercise B. Anyway, let's just continue on number 3. Here for number 3, we'll just simply apply the same processes. So again, case 1, we'll be taking the whole quantity x minus 3 and equate it to the positive value here, 10. Case 2, we'll take again the same quantity x minus 3, but will be equated to the negative of 10 and solve them independently. So instead of earlier, it was subtracting by 5 because that was positive 5. Here, it's minus 3. So I will add here 3. Okay, again, different from here. So we also add here 3. Same thing here, add 3, add 3. So that becomes x is equal to 10 plus 3. This is 0 already. 10 plus 3 is 13. The other side, 0. X is equal to negative 10 plus 3. Again, go back to your integers. You might say negative 13 because again, sir, sabi mo kasi niya, sir, opposite lang. Hindi opposite lang din dito. Not all of the time they are opposites. Simply use the correct processes here. So instead of having it a negative 13, that's actually just negative 7. Negative 13 plus 3 is negative 7. Checking. Checking. So again, original. So you have x already, which is 13 minus 3. Is it 10? The other side, negative 7 minus 3. Is it? Again, not this one, that the original. Is it positive 10? So 13 minus 3 is 10. Absolute value of 10 is 10, equal to 10. Acceptable solution. That's it. Next, you have here negative 10, because negative 7 minus 3 is negative 10. Absolute value of negative 10 is positive 10. Positive 10. They are equal. Therefore, negative 7 is a solution. If some of you will still stick, sir, my answer is really negative 13. When you substitute it here, negative 13 minus 3 is actually negative 16. The absolute value of that is 16 and will not be equal to the right hand side, which is 10. This is another proof that you really need to review your integers here, because if you will come up with negative 13 and will declare automatically your solution set without checking, everything will be incorrect. Okay? So again, please review your integers. Now that we are sure of the two, solution set is a set containing 10 and a 10. Sorry, 13, this one, and negative 7, or vice versa, can be interchanged. Let's proceed to our last example for practice, our last item for practice exercise A for this lesson. Again, same. Take this and equal to the positive 3. The other case, take the same value and equate it to the negative of 3. Then solve them independently. So this given item here is an absolute value equation, but when you apply the cases, two cases, you will be returning to linear equations in one variable without the absolute value notation. So that means need to review the previous grading. Let's start with by adding 1 both sides. Same here, that becomes 0. So you have the value here, 2x is equal to 3 plus 1 is 4. But we are not yet done. We need to divide both sides by 2. So x is equal to 2. Here, again, that's also 0. So you have 2x is equal to negative 3 plus 1 is negative 2, not negative 4. Divide both sides by 2. So you have the value of x is equal to negative 1. They are not opposites. Not all the time that they are opposites. Let's do the checking. We will use the original given equation. So you have 2 times 2 minus 1. Is it 3? Let's check. 2 times 2 is 4 minus 1, 3. 4 minus 1 is 3. Question mark still. Absolute value of 3 is 3. The other side is just a 3. They are the same. Therefore, this is a solution. For the second checking, so you have 2 times negative 2 minus 1. The absolute value of it is it positive 3? Again, not this one, but the original equation. So 2 times negative 1 is negative 2 minus 1. Okay. Negative 2 minus 1 is negative 3. The absolute value of negative 3 is positive 3. The other side is also positive 3. They are the same. This accepts negative 1 as a solution. Since both of them are already solutions, so our solution set is a set containing 2 and negative 1. As a review, our solution sets contains 2 possible solutions. If, I'm just saying this as an if in case this will not be equal, if lang po, that means negative 1 is not a solution. So your solution set should only contain 2. That is if this is not equal and this will not be a solution. Okay? It shall only equal, the solution set should only contain the solution, which is actually the value of 2. But since we have checked it earlier, that one negative 1 is really a solution, so both of them are acceptable. We might see this those instances wherein some might not be solutions in the next practice exercise. But as of this practice exercise is concerned, this is how it's done. So please continue practicing and reviewing as you prepare for our assessment soon. Goodbye.